Metallic bonding. So you're going to go to lafellabs.com and go to Unit 2, and you should find the PowerPoint there that is for metallic bonding. And you're going to complete that PowerPoint while answering questions. So whenever you are done and you are ready to review your work, you can return here to check your answers. So how do metals form cations? So metals tend to have pretty empty valence shells. So they're going to get to an octet by losing electrons. This means that they're going to form cations. So for example, if we look at something like sodium, sodium is going to get rid of this 3s1 electron. We get rid of that, and now my second energy level has a full octet. So metals are going to tend to lose electrons in order to get to that stable octet electron configuration. So where do the electrons in the Electron C come from? So each metal atom is going to give up some electrons. Those are going to form the Electron C. So we want to draw a picture that shows the Electron C model. So in the Electron C model, we have our metal cations. In this case, this is probably something like aluminum, something that has 3 valence electrons. And each of these electrons is going to become delocalized. What that means is that it's not shared between 2 atoms or held in one place. Instead, those electrons are shared amongst all of those metallic cations there. So we call this an Electron C. So a caption for our picture would be something like metal cations are held together by the Electron C, which prevents the cations from repelling each other. So now we want to explain the properties of metals in terms of the Electron C model. So some of the properties of metals, the first one is that they are shiny. So the electrons in the Electron C can easily re-emit light, so they can absorb and re-emit light. We saw this when we talked about the Bohr model and the flame test. So all those electrons are able to easily absorb and re-emit light, making metals shiny. Metals are also good conductors of both heat and electricity. And that's because we already have free-flowing electrons that can carry that energy as they move. So those free-flowing electrons in the Electron C are going to make metals good conductors. In fact, electricity is really just a flow of electrons through a metal wire. Metals are also malleable and ductile. What that means is that when you hit them with a hammer, they're going to bend rather than break. And that's because the electrons in that Electron C insulate those metal cations from touching each other. They kind of act like grease between ball bearings. So those cations are able to slide past each other, and the metal bends rather than breaking. So looking at the metallic bonding model, we're going to talk about what an alloy is. So an alloy is going to be a mixture of 2 or more metals. It may also contain some nonmetals as well. And to change our model to reflect the structure of an alloy, we're going to want to switch out some of those metals. So we used beads to represent our metallic cations. So if we switch out those beads so that we have 2 different kinds of beads, that would better represent an alloy. So you can go ahead and answer Journal Write 6. So we want to look at that bead model of the Electron C, and we want to examine what does it illustrate well, and what changes could you make to create a more accurate model. So what are the limitations of this model? What does it show well? What does it show not so well?